very much, Madam Madzivadondo. Thank you very much, Madam Madzivadondo. And I would like also to acknowledge Dr. Chiparausha, the University Librarian for Bindura, as well as distinguished guests that have managed to join us for this webinar. Big data opportunities for researchers. So this is basically what we are going to be talking about during this webinar. We're going to have a brief introduction, then we will talk about what big data is all about, trying to look at various definitions that have been coined. We're also going to look at the characteristics of big data, along with the types of big data, sources of big data, and then we'll talk about the real meat of the discussion, where we'll be looking at the opportunities for big data in research, how to use big data, as well as challenges that are there when it comes to making use of big data. So it is a fact that today the most valuable resource is no longer oil, but it's now data. That is why it is important to pay attention to big data and to look at opportunities that arise as a result of it, especially for researchers. So it's obvious that many researchers worldwide are taking advantage of big data. And it is also important for researchers within our institutions to also look at the opportunities that are offered by big data, because it promises to revolutionize the production of knowledge within and beyond science, and by enabling novel, highly efficient ways to plan, conduct, and disseminate, as well as access research. So big data actually offers an opportunity for all researchers in all disciplines to be able to make use of different data sources, as well as improving the accuracy and predictive power of scientific findings, as well as being able to identify future directions of scientific findings. And helping also in the course of starting an empirical investigation. So big data really offers a lot of opportunities for researchers to engage in research in new ways, and in some cases in ways that were not previously possible. So that's the reason why really researchers need to really pay attention to big data. But what is it? What is big data? How can we define big data? The various definitions that have been offered, but there is no specific definition really. But lately, as I will explain, there were efforts to provide a more specific definition of what big data is. But from my screen there, you are actually able to see some of the definitions that have been offered. The first one there, datasets whose size is beyond the ability of typical database software tools to capture, store, manage, and analyze. And another definition says that datasets which cannot be captured, managed, and processed by general computers within an acceptable scope. So we can see a similarity there. And again, the third definition, big data refers to datasets that are too large, complex to be dealt with by traditional data processing application software. So we can see the keywords there from the first three definitions, that big data actually refers to those data sets that are not handled by typical database software tools, by general computers, and also by traditional data processing application software. So as long as typical, general, or traditional computer application software are not able to handle such kind of data, then that data can actually be referred to as big data. But another 2018 definition there, which is basically the fourth definition from my slide, defines big data as where parallel computing tools are needed to handle data. And the 2020 definition also highlights that the big data can actually refer to large data sets that are produced in a digital form and can be analyzed through computational tools. So here, I think we are beginning to appreciate what big data is. But perhaps the most useful way of defining big data is looking at the characteristics of big data. So originally, when the wave of big data started, big data was originally associated with three key concepts, or with three key dimensions, which are volume, variety, and velocity. But later on, with technological advances and interest from various researchers, other views of big data were also added, such as veracity and value. And these views are not actually limited to these five, but more have been added. But perhaps for the sake of this presentation, I've just decided to settle on these 5 dimensions. So looking at each and every one of these dimensions will actually help us to define further what big data is, and looking at its characteristics. And this will help us really to appreciate also what we can do with it. So perhaps I thought that this is very, very important to look at. So let us look at these characteristics one by one. First of all, let us look at the volume aspect. So what do we mean when we are talking about volume as a dimension of big data? So volume basically indicates the size of the data. Perhaps the question that you can have in your mind is, so how big should big data be to be defined as such? Well, big data size is a constantly moving target, and it really depends on the field and perhaps on the sector. So there is no there's no defined size in terms of maybe gigabytes or terabytes that we can say, okay, if you have 100 terabytes, then that is big data. No, it really depends on the field or the sector. And also, what is important to realize is that what is considered big data today, tomorrow, it cannot be considered as such. Because remember, from our previous definitions, we're talking about big data is big data if it cannot be handled by traditional, typical, or general computers. But what if what we define as big data today can now be handled by general computers tomorrow? Then that means that it can no longer be defined as big data. So we can actually see that big data size is actually a constantly moving target as such. Then let's talk about velocity is another dimension of big data. What do we mean by velocity? So we are talking about the high speed of accumulation of data. Basically, velocity, we are talking about the pressing speed with which data is generated and processed. So I'm sure you can agree with me that the rate at which data is being generated and processed is such that it's actually growing at a breakneck pace, and in such a way that it is impossible for the human cognitive system to be able to comprehend all such information as it is being generated. And as such, there is need for some form of automated analysis to try and understand the big data that is constantly being generated. So by velocity, we are basically talking about the speed of accumulation of data. So this is another way of characterizing what big data is by looking at its velocity. Then another way is variety. So this is another dimension or characteristic of big data. So what do we mean by variety? Here we are talking about different formats of data from various sources. So we are talking about, for instance, different types and modalities for a given object in consideration. So we can give an example here. For instance, for a given object, big data can actually exist in the form of perhaps images, audio, video, free text observations. It can also be including humidity measurements, GPS coordinates, and etc. and etc. So that's the variety aspect of big data. So big data comes in a variety of formats and also from various sources. So that's another way that can also help us to understand what big data is. So we have now talked about 3 dimensions. So what is the first one, the fourth dimension that you also want to discuss? This is now veracity. Veracity, what do you mean by veracity? Veracity, we're talking about the trustworthiness or the quality of the data. So one thing that is a characteristic of big data is that there's a lot of inconsistency and uncertainty in the data. So big data is actually laden with a variety of inaccuracies. It could be errors. We can think about things like missing values. There is a lot of noise, and also there is a lot of imbalance in times. So this is another characteristic of big data. So as we work with it, we also want to be aware of this big characteristic of big data. Then another way that we can also comprehend what big data is by looking at the fifth dimension, which is value. So what do we mean by value? So some look at big data as having value if it has the ability to be monetized. Okay, so we know that there are a lot of companies that are actually riding on this where they're actually monetizing the data that they have, the big data that they have. So this is one way in which big data is becoming to be known by looking at its value. But of course, the value that is attributed to big data can depend, depending. Perhaps, for instance, I can use this example that maybe different sections of society which depend maybe on data, they can attribute the value of big data in different ways. And we can also think about researchers. They can also attribute the value of big data in different ways. Perhaps they can try to attach financial, ethical, or even reputational value on big data. So that's another way in which big data can be known for by looking at its value as it were. But maybe the most important aspect when it comes to value is maybe to just look at whether the data has the ability to be monetized, because I think that is the most important thing for most people when it comes to big data. So those are the basic 5 dimensions of big data that actually help us to understand what it is beyond the definitions that we have just highlighted. So this list of features that we have just discussed is not exhaustive. I think that's something that is important to highlight at this point. And it also shows that big data is not simply a lot of data, but there are many aspects that are involved, as we have seen. So here we've just talked about at least 5 dimensions or characteristics of data, which helps us to understand what it's all about. But let's look at types of big data that are out there. I think this is something that is also important to understand as we discuss this subject of big data opportunities for researchers. So what are the types of big data that are available? So the first one is structured data. So from the pic that is on the slide there, I'm sure you are actually able to appreciate that this is the kind of data that is the simplest to organize and search. So perhaps it can include things like financial data, maybe machine logs, or it can be demographic details. So a very good example of structured data is when we think about the Excel spreadsheet with its layout of predefined columns and rows. So this is a good way to try and envision what structured data is all about. So this is the first type that we've just discussed. What about the second type of data? This is semi-structured data. So from the very phrase semi-structured data, we're actually able to pick out that this is a hybrid of structured and unstructured data. So what example can we give to try and appreciate this? Maybe we can think about emails. I think they include both structured and unstructured data. How so? For example, when we think about the structured element of email, it is a sender, recipient, subject, and date. But when we are now talking about the body of the email, there's a lot of unstructured data that can be in the body of an email, because it can include text, it can include images, it can include videos, so a variety of data types. So that's what we mean by semi-structured data. So this is just but one example that I have just given to try and explain what semi-structured data is. Then the third type of data now is unstructured data. So big data philosophy encompasses unstructured, semi-structured, and structured data. However, the main focus is actually on unstructured data. I think that's also something that is important to appreciate. So in as much as there is structured data, there is semi-structured data, is types of big data, but the main focus when we are talking about big data is actually on unstructured data. So what is unstructured data? Okay, maybe for us to understand this, making use of examples can actually assist us. So this category of data can include things like your social media posts, it can include audio files, images, open-ended customer comments. So this is the kind of data that cannot be easily captured in standard row column relational databases. I think this is one way of putting it simply, trying to understand what unstructured data is. So if ever a researcher is going to be working with big data, they really need to understand its unstructuredness, because this will then inform how they are going to go about gathering it, storing it, and also analyzing it. So these are just examples of structured and unstructured data types that we have just discussed. Perhaps we can actually move to the next segment of this discussion, where we now want to talk about sources of big data. I'm sure researchers would like to know where they can actually get this big data for their own research. So this slide actually shows a lot of possibilities for big data sources. It can be found in various sources. It can be your Internet of Things devices, it can be your social media, it can be in anything. And as we can see from the slide, there are so many sources there. But what is one way in which we can be able to comprehend easily the sources of big data? Perhaps it is by breaking down these sources into 3 categories. So let's look at the first category of what we can refer to as a big data source, so that we can be able to comprehend the various sources of big data that are available. So the first one is social data. So as you can see from the slide there, social data is actually generated using a variety of social media platforms. And this can be social media comments, it can be posts, it can be images, and it can also be video. So there is a lot of big data that is being generated in these social media platforms. And this data can actually be a rich source of raw data that can be also be manipulated by researchers and gaining useful insights. So it's important to appreciate that a very big source of big data is actually social data. So that's something that is important to note. Now, let's look at the second source of big data. Now, this is machine data. So what do we mean by machine data? Well, we can think about the various Internet of Things devices and machines which are fitted with sensors and have the ability to send and receive digital data. So these sensors can actually assist researchers to be able to collect and process machine data from various devices. It can be vehicles, it can be equipment. And the rate at which these devices are actually growing is actually at a very rapid pace. So we can think about sensors that are being used, for example, for weather forecasting. It can be, sensors that are being used for traffic monitoring and so forth. So it is actually expected that there are maybe over 40 billion of these Internet of Things devices on Earth, and that are actually generating almost half of the world's total digital data. So this is another rich source of big data for researchers. That is machine data. Now, what is the third one? The third source. Now, this is now transactional data. Now, we want to give an example here of a large international retailer. For example, that is Walmart. Walmart is known to process over 1 million customer transactions every hour. So you can just imagine by the end of the day, how much transactional data would have been generated. So this transactional data can also be structured, but sometimes it can also be semi-structured, including things like your images and comments, and making it more complex to manage and process. So this is another rich source of big data for researchers. So I think this is a good way to try and look at sources of big data. So as we have seen, we can see that we can basically categorize sources of big data into three. The first one being social data, the second one being machine data, and the third one being transactional data. Now let's now look at the opportunities for big data in research. Big data actually presents unparalleled opportunities to accelerate scientific discovery and innovation. So we want to see the various ways in which these opportunities can actually be presented for researchers. So from this slide here, we can actually see that big data offers an opportunity for researchers in different subject disciplines or domains. We can think about, is it banking, is it insurance, is it transportation, is it education, manufacturing, energy, healthcare, media, and entertainment. So in fact, each and every researcher in each and every discipline is actually presented with an opportunity for big data. So big data is not just limited to a specific discipline, but researchers in various disciplines can actually be able to take advantage of big data. So let's look at the opportunities that are there, for example, in healthy care. Big data can be used to analyze large data sets of patient records to identify patterns and trends that can help improve patient care. So that is in healthy care. But of course, there are other things as highlighted in that picture there in my slide, whereby big data can also assist with predicting maybe the spread of epidemics. It can assist with clinical decision support system. It can also be useful in telemedicine, personalized medicine, preventive health care, and also fraud management. All this being applicable in healthcare. So much can be said about how big data can be very useful for researchers in this particular discipline. What about environmental sciences? What opportunity is there for researchers? Well, we can say that big data can be used to analyze large data sets of climate data to better understand the causes and effects of climate change, perhaps track the movement of animals, and also monitor the health of ecosystems. So this is a very good example of how big data can assist when it comes to environmental sciences. Perhaps this information can actually be then useful to develop policies and strategies to mitigate climate change, for instance. Then big data can also be very advantageous in the energy sector, where it can actually be used to improve energy efficiency and to reduce emissions. So we can give an example there. For example, big data can be used to track energy usage in a building, and of course, to optimize the operation of power grids. So we can see that researchers in this sector can use big data in these ways. What about in transportation? Big data can also be used to improve perhaps traffic flow and to reduce congestion. We can give an example there. Big data can actually be used perhaps to track the location of vehicles and also to predict traffic patterns. And this information can be disseminated in real time, helping road users to be able to see the best way to navigate their way to their particular destination. Then collaboration is another opportunity that is presented by big data. Big data can actually facilitate collaboration between researchers from different disciplines. This is because big data most of the time actually requires a multidisciplinary approach to analysis. So we can have a situation whereby a problem that researchers wish to solve can actually involve researchers from various disciplines. It can be from economics, natural sciences, social sciences, and so forth. And all these researchers that can actually be able to collaborate and solving a common problem of interest. So we are having a situation whereby various data sets from different areas can actually be integrated in such a way that meaningful insights can be drawn. So what an opportunity for researchers that is also presented, helping them to collaborate. Then in terms of security, big data can also be used to identify patterns of suspicious activity, especially used for fraud management. What about social sciences? Is there an opportunity for researchers to use big data in social science? Yes, big data can be used to analyze large data sets of social data and to understand human behavior, social networks and trends, and also to predict future events. So this is especially applicable to researchers who are interested in computational social sciences. They're actually able to use application programming interfaces, also known as APIs, that are provided by big data holders such as Google and Twitter to do research in social and behavioral sciences. And one thing that is important to point out is this, that some of these APIs are actually provided for free. So it's just, it's a matter of a particular researcher just learning a few things, especially the documentation of a particular API, in order for them to be able to know how they can actually be able to download data of big data of interest from some of these free providers of big data. So really, we have now appreciated various opportunities that are actually presented for researchers in various disciplines, how they can actually be able to make use of big data. So all disciplines are covered, so it's something that is encouraging. So this is actually an opportunity for researchers who want to perhaps specialize in how they can be able to publish using big data. So it takes a little bit of effort, but something that can actually be done. So how can we summarize how a researcher can be able to make use of big data? Well, the first thing that they need to do is to gather the big data. So they need to bring together the big data of interest from many possible sources and applications. So that is the first step. And of course, there are so many things that can be involved. This step, maybe it can also include the formatting of the data, so that it is formatted in such a way that it can then be stored and analyzed. Then the second aspect has to do with the storing of the data. So you need to store it somewhere. There are many options that can be available. You can store it perhaps on the cloud, on the premises. But one thing for certain is that if you want to make use of big data, sometimes you cannot be able to use it in its original location. You need to gather it and then store it somewhere for you then to be able to analyze it, which is the third step. So those are the three basic steps that a researcher needs to go through, and there are a lot of technical details that are also behind these three steps that we are actually not able to cover in detail in this discussion. Perhaps one thing for certain is that researchers need to be aware of big data technologies that can actually assist them in gathering the data, storing it, and analyzing it. So it might take a little bit of effort, as I have highlighted, for researchers to be familiar with some of these technologies. They can involve statistical analysis, data mining, data visualization, text analytics, social network analysis, signal processing, as well as machine learning. So these are things that researchers really need to be familiar with if at all they want to take advantage of the various opportunities that are presented by big data. Now, let me just run through quickly some of the big data challenges that are there. These are challenges that researchers really need to be mindful of when they are working with big data. The issue of data quality being the first one. So big data can vary significantly in terms of quality. And the researchers, they need to carefully evaluate the data before they use it. So that's one thing that is very key. Then data availability. So not all big data is publicly available, something that needs to be acknowledged. So researchers may need to contact the data owners to request access. Then another challenge has to do with data privacy. Big data often contains sensitive personal information, and researchers need to be careful how they use and share this data. And last but not least, in terms of data security, big data can be a target for cyber attacks. For example, you've gathered your data and you've stored it in the cloud, trying to analyze it. Someone can attack it. So researchers need to take the steps to protect their data from unauthorized access. So these are some of the key big data challenges that are out there that researchers really need to be mindful of as they try to work with big data. So in conclusion, what can we say? Well, we can say that big data promises to revolutionize the production of knowledge within and beyond research by enabling novel, highly efficient ways to plan, conduct, disseminate, and access research. So researchers in all disciplines can actually take advantage of big data, and they can actually be able to come up with new solutions to problems that are actually affecting society and the world at large. So this is basically my presentation. Thank you for your attention, ladies and gentlemen.
Thank you very much. Thank you very much, Mr. Ndlovu, for that wonderful presentation. And I think, colleagues, you can all agree with me that this was really a wonderful presentation where you managed to share with us one of the contemporary issues that is there in the world of research, the issue of big data. My name is Stephen Sekea. I'm the sub-librarian. I have been given 15 minutes to look into question and answer. If there are any question and answer that participants are willing to share, let's hear them. Our facilitator is around. We will be able to discuss with us. Let's take this opportunity to share whatever we know on big data. But Mr. Ndlovu has really managed to open our the discussion for us on what big data is, and to demystify that it is not just about a lot of data. Big data presents a lot of opportunity for us as researchers. We need to take advantage of it in whatever discipline, be it the commercial, social science, the arts, agriculture, environmental science, and so on. All these disciplines, there are opportunities for big data. Now, you are free, colleagues, to use the question and answer platform. If you have challenges with your audio, with your mic, just raise your hand if you need to make any question. But if I may start, Mr. Ndlovu, if you can hear me say, when it comes to analysis of big data, what opportunities are there for researchers, especially in the Zimbabwean context, to get some training on how to analyze big data.
Okay, thank you, Mr. Tekea, for your question there. So I think there are a lot of opportunities in terms of analysis. I think most researchers are actually aware of a facility at the University of Zimbabwe there, where they have a supercomputer that is actually was actually installed for the purposes of analyzing big data as it were. And from my understanding, they are also into providing training for researchers who wish to use this super computer. And indeed, it's an opportunity for researchers also to be trained on how they can actually be able to, analyze big data. So it's an opportunity that is there, that is actually available locally. But of course, the researchers can also take advantage of free webinars that are available on the internet, depending on their subject discipline. I think there are special interest groups that are available in each and every discipline, where researchers can actually be able to explore and learn more about using big data and as well as analyzing it.
Thank you very much for that response. Any other question, colleagues?
Yes,
We are also
Mr.
free
Tekea.
to use the question and answer platform. Yes, I can. Please come through, say.
Thank you. I wanted Mr. Ndlovu, the facilitator, to also explain to us if there is any difference between big data and any other ordinary data, not in terms of size and the other things that he has presented on, but in terms of its credibility and in terms of how it should be used and so on. For example, should we treat the big data the same way we should treat any other ordinary data that we gather from research? Are there any differences for researchers? Because some might be skeptical to say, if I use big data, I'm not going to carry out a credible research. Issues like that, maybe if you could clarify. Thank you.
I think what I can say in response to your question, Dr. Shparasha, is that big data can actually be equated to any other data that we've become to be aware of. But what is important to appreciate about big data is its characteristics. We have talked about one of the dimensions being veracity, big data being synonymous to inaccurate data. Sometimes there's a lot of missing data there. And there's a lot of imbalance, a lot of noise. So it's all about trying to make sure that as you gather the data, you also try and make sure that you cover for these inaccuracies that are there in big data, so that whatever findings that you are going to table are really going to be meaningful and are really going to be insightful. So I think that's what I can say in response to your question. It's all about appreciating that big data is laden with a lot of inaccuracies that a researcher really needs to take account of as they work with it, so that they can be able to produce meaningful results.
Thank you very much for that response, Mr. Ndlovu. Any other question? I can see there is a question on the share. May you share on the level of adoption at your institution and perhaps your experience? This is a question from Ms. Majojo. Mr.
Actually,
Ndlovu.
I think this is one question that I wanted to pose to participants. I wanted to find out whether some have tried to take advantage of big data. Perhaps we can hear from the participants as well. They can. I'm not trying to appear as an expert in the area. Perhaps we have researchers among us who have actually used big data. Perhaps they can share their experiences as well in trying to make use of big data.
Yes, participants, let's hear your stories. Are there any institutions that have really adopted the use of big data? Whilst we are waiting for responses from institutions, there's also a question that has been posed on any research collaboration opportunities for research with BUSE, and not only BUSE, but with other institutions. I think there are plenty where people can share a lot on the researches which they are currently doing. There can be collaborations between researchers. Opportunities are there. We have heard from Mr. Ndlovu on the opportunities that are there. Let's utilize such opportunities. Is there anyone who would want to share their experiences? Okay, if not, I can see that there are no questions that are coming through. Perhaps we can go to our last session, where I'm going to invite the BUSE librarian, Dr. Chiparosha, to give some closing remarks. Dr. Chiparosha, are you there?
Yes, I'm there. Thank you. Maybe to just comment on the question with regards to adoption of big data. I'd like to point out that probably many researchers have been using big data, but unknowingly. That is what I would want to say, because if you make reference to the presentation earlier on, Mr. Ndlovu mentioned a lot about the various sources of big data, and I liked the machine data, which is more to do with machine learning and artificial intelligence. And he also talked about social data, which is generated using social media. I have keen interest in those areas because that's where my heart is. But I would like to point out that a lot of researchers are unknowingly making reference to big data, but at the back of their minds without realizing that they are already into it. There is a lot that is going out there, but the moment you want to mention that let's utilize big data, some become hesitant, skeptical, and so on. But the bottom line is we cannot do research without making reference or without consulting or without, to some extent, having support of big data. But what I would like to point out is that there is need for us to be deliberate, be cognizant, and to be proactive with regards to use of big data. And I would also want to thank Mr. Ndlovu for pointing out that big data is like any other data. And he pointed out one thing, that there is a lot of noise. I hope researchers understand that term very well, that there is a lot of noise in big data. The same applies to any other research. This is why data analysis is required, because it removes the noise, it brings order, it transforms the collected data into something meaningful, which we refer to as information. So thank you very much for that. But going back to what I've been asked to do by Mr. Tsekea, I would like to take this opportunity, first of all, to thank Mr. Ndlovu for spending the last 60 minutes presenting to us, responding to our questions, and articulating in detail, great detail, about big data, and most importantly, about the opportunities available. I would also want to take this opportunity to thank all the participants. I was checking the maximum that we managed to reach was nearly 4 dozens of participants there who were following the presentation religiously. Thank you very much for taking your time to follow this presentation. And as my closing remarks, I would want to say this to researchers, to policymakers, to librarians, and anyone else. I want to point out that we are living in a new millennium. We are living in an era where we are making reference to the 4th Industrial Revolution. And if you check some of the key pillars of the 4th Industrial Revolution, you will find out that machine learning, big data, artificial intelligence, and related technologies are the business of the day. We cannot move away from that. And I would like to make reference, and I will quote what Mr. Ndlovu said. He said, oil, that is petroleum, is no longer the key resource for this millennium, but it is big data. So in whatever we do, ladies and gentlemen, let's take note that big data is the in thing. And if we want to partner, if we want to get funding, if we want to be visible, if we want to be relevant, and if we want to live a happy and perfect life as a researcher and as a citizen of this digital economy, we cannot run away from big data. Having said that, I would like to say thank you very much. And I also want to point out that opportunities for research and collaboration in this area are wide open, and everyone is welcome. Thank you and a good day.
Thank you very much.
Thank you. We've come to the end of our presentation, and goodbye, everyone.
Oh, thank you.